Hey guys, what's up? Mr. Brotherton here. Today we're going to be talking about relationships, okay? These relationships between animals, specifically predation, competition, and symbiosis, which is one of my favorite topics. Before we get there, though, what's the importance of understanding ecological relationships? Well, I'm going to kind of tell you a story of how this relates to our last thing about succession, what we were talking about when we were talking about the Carboniferous period and how that impacts our current use of coal today, and a little bit about how we got here. All right, so let's go back before the Carboniferous period. Okay, let's go back to 700 million years ago. And as we talked about with our succession stuff, the first things that are going to be able to move into an area are going to be lichens. Remember, lichens are a symbiotic relationship between a plant and a fungus, and sometimes even a bacteria. And you need these to move into a place initially because they help to break down rocks and start forming soil. So 700 million years ago, there actually wasn't soil on planet Earth because nothing was living on land to make that soil. All right. So at the beginning of the Silurian period, which is 440 million years ago to 420 million years ago, you start to have a new thing come onto land, a new type of fungus that starts interacting with these lichens and starts interacting with algae, and that's called a mycorrhiza. And we still have these today. Mycorrhiza are the largest organisms on Earth. Okay, you might not know it, but you've actually encountered these before. When you're looking at a mushroom, you're actually looking at the fruiting body of a mycorrhiza. And what's cool about these is they help distribute nutrients throughout the environment. So they have relationships with plants. So first you have lichens 700 million years ago. By 420 million years ago, you have mycorrhiza interacting with plants, and now you're starting to build up soil on land before we can get to that Carboniferous stuff we were talking about. But today we're mainly going to be focusing on the next period of time after the Silurian, which is the Devonian. So during the Devonian, 420 million years ago, you start to have the first invertebrates actually colonizing land. So here's a picture of this early arachnid type creature that was actually colonizing land, and there still wasn't much soil. Okay, but eventually, by the end of the Devonian, right before the Carboniferous period you guys have learned about, we get stuff like this. We get these full, awesome, really cool swamps. Okay, so it's a symbiotic relationship between a plant, a fungus, and a bacteria that actually allows us to develop soil and for life to start moving from the oceans to land. Okay. So finally, the last thing I want to show you what's really super cool about the Devonian and gets me excited is the first vertebrates that actually start moving onto land. Okay, what's incredible about these guys is if you look at Tiktaalik or Ichthyostega or even the coelacanth, which is actually still around today, when you look at these guys, a lot of the things that made them successful on land, these didn't evolve after they got to land. They actually already had them. So back in the day, Darwin said that a lot of adaptation is probably actually just a change of function, okay, not a new structure. And when we look at the fossil record, it turns out he's right. Tiktaalik, Ichthyostega, a lot of these things actually already had limbs. They actually already had lungs. They were just using them in different ways. But once we have this lichen and these invertebrates and all of this stuff building up soil, now you can start to have these guys living in more shallow areas, right? Because there's not as much runoff, because now there's soil, there's plants holding them together. And something like Ichthyostega and Tiktaalik can kind of start moving onto land. So what's the point of all of this? The point is that succession can take a really long time. Remember, we said primary succession can take a long time after there's a disturbance. Well, the very first primary succession, getting from bare rock all the way to tetrapods walking on land, took 300 plus million years. Okay? And the other important thing here is that relationships between organisms actually drive biodiversity and they drive evolution. So as these relationships are taking place, animals can start to react in new ways. What's the last important thing? Well, the loss of these organisms and the loss of habitats can take a really long time to recover from. Okay, the first time this happened, it took 300 million years, okay, to get to something that kind of looks like what you would recognize as planet Earth today, as land today. I mean, that took 300 million years from the first time that a lichen moved onto land. Okay, we're talking, we're about 3.5 billion years into the history of Earth here. So it took a long, long time for this to happen. All right, so predation, competition, relationships, symbiosis, all this stuff is super important because it actually changes our planet and it actually changes the way life kind of moves through, and it changes how they adapt and evolve, which I think is really, really cool. So when you really learn about it, you're like, well, why wasn't Tiktaalik and Ichthyostega on land earlier? Well, they couldn't be because there weren't habitats there, okay? So why do organisms interact? Well, there's only a limited amount of resources and they have to share the habitat. So a habitat is the area you're going to be sharing in an ecosystem, and it's where that organism is going to live. So you have both abiotic and biotic resources. So the abiotic resources are like the raw nutrients that something like a lichen is going to be breaking down and then transferring throughout the environment so other organisms can use that, all right? So every organism has a unique niche, okay? This is the idea that all of the things that an organism needs and does with its habitat or its niche, okay? This is from the French word for nest. So a niche is how you use what's in your habitat specifically to propagate your species, so to keep your species alive. So you can have multiple things living in a habitat. Like right now, my house, you could say, is, in this temperate environment where we live. But the way we are using something like my house is a lot different than the way maybe if we step right outside my house that the fish in the stream by my house are using this habitat, or the frogs in my backyard are using this habitat. So we share the same habitat, but our niche is different. We have different energy resources, and we use the abiotic and biotic things differently. So what's something really important here is predation. Everything has energy needs, all right? We talked about that. That's one of the things that makes life alive is it needs to consume energy to keep going. So predation is when one animal eats another for food. So your predator is the organism that's going to hunt and kill another for food. Your prey is going to be the thing that gets consumed. Okay, what are some examples? Well, a bear eating a fish, an owl eating a mice. Okay, all of those things are examples of predation. All right. What's interesting about predation and prey relationships is there's kind of a cyclical pattern there. So it's a cycle of how the population is going to change over time. So we're really starting to put some things together here because we were talking about how populations grow earlier as well. So let's see what's happening at point A. So if we look at our graph here, we can see our prey population is rising, and we can see our predator population is rising along with it. But now look what happens. Our prey population drops, and sometime later, our predator population drops. So you can imagine that how prey is doing is going to directly correlate to how their predators are doing. And if the predators maybe start to eat too many prey, well, then our prey's population are going to drop. Then our predators are going to have a hard time as well, and then their population is going to drop. So these could be responding to one another. Now, what's happening here? What's happening here is maybe a pretty bad disturbance, okay? Maybe something really bad has happened here. You can see our prey is dropping. Maybe something's happened in their environment. Maybe parts of their habitat have been destroyed because this is a really big drop that we're seeing. So the prey drop, and then after they drop, once again, our predators are going to start to drop as well. So the predator-prey relationship is incredibly important. And when we kind of mess up one thing in an environment, it can have these cascading effects that ripple throughout the larger ecosystem. So what's competition all about? Well, competition is a relationship that exists when two or more organisms are fighting for the same limited resource, okay? This is like growing up, my little brother and I would always fight over that last slice of pizza. You know, that is competition. So it can come in two forms: interspecific competition. So that's competition between different species, okay? So think about the internet. You're connecting to other computers. You're connecting to the world outside of you. So think international. And you can also have intraspecific competition. So that's where the competition is occurring within the same species. So my little brother and I fighting over that last piece of pizza, that's going to be intraspecific competition. And when our dog just walks over and grabs it off the table while we're fighting over it, well, that would be interspecific competition, and my dog won out in the end. Okay, so intraspecific, think intramural. Okay, so it's within a league. All right, so intra is within, inter is between different species. This is a really important idea in ecology, and it also is a driver of evolution. It's the idea that no two organisms can occupy the same niche at the exact same time. So we call that the competitive exclusion principle, because the competition is so fierce that one organism is excluded from accessing that niche. So that means that no two organisms can eat exactly the same food, can have exactly the same needs, okay? They can't be in the exact same place at the same time. It's not going to work, all right? So if the organisms are very different, one is going to probably be a better fit for that environment, and it's going to exclude the other one from accessing those same resources. So when we talk about, say, an invasive species, like emerald ash borer or something like that, what you're really talking about there is an invasive species because it maybe doesn't have any natural predators in an area. It can outcompete the things that were already there, and so the things that were there start to die off, okay? And the thing is, a lot of times what's going on here is organisms are going to fight, and they're going to see who is going to win, okay? And generally, you're going to start to see species move to different areas, or in the case of different populations, if we think about the Lion King, right? Mustafa loses to Scar, so his population gets to take over, and he gets to take over that habitat and that niche. Whereas it's not until Simba comes back later and then he outcompetes. So you can't both be in the exact same place at the same time, okay? And then we come to the idea of symbiosis. So this isn't any interaction that involves a close physical long-term relationship between two species. So symbiosis literally means living together. Okay, so right here you have an example of this buffalo with all these birds hanging out on its back. What do these birds get? They're probably getting to eat whatever pests may be on this buffalo, and then the buffalo's happy because it's getting the pests off of it. Okay, so in symbiosis, one species is always going to benefit, and this is always going to be interspecific, so between two different species. So this is not intraspecific, this is always going to be interspecific. So relationships within a species are not symbiotic, okay? That's just them helping each other out. You could say it's altruistic. If I hand someone that last slice of pizza, even though I really want it, that's not symbiotic. That's being altruistic or being kind, all right? So symbiosis is living together. That always means with a different species. There's a couple different types. The first one you're probably most familiar with is parasitism. This is when the parasite benefits from the relationship and the host is going to be harmed. So this disgusting picture of these ticks in this dog's ear, that's going to be a parasitic relationship. The way I think about this is a plus minus, okay? So one of them is going to benefit, the other one is going to be harmed. So if you think about like a mosquito as a parasite or a tapeworm or any of that kind of stuff, one thing is benefiting, the other one is going to be harmed. The host is going to be harmed. So the thing about being a parasite is you don't want to kill your host. Why? Because if you kill your host, you've essentially destroyed your habitat, because your host is basically your entire habitat. all right? You want that population to just kind of be able to spread you, okay, throughout them, and you don't want to kill them. So once again, if we think about parasitism, this is going to be a density dependent limiting factor, because the denser a population is, the better these parasites are going to do. Okay, it has to be able to spread throughout the population. Commensalism. So this is a really good one. One organism is benefited while the other is going to be unaffected. Okay, so it's not really benefited or harmed. So an example of this is kind of like these barnacles hanging out on clams. They're not really, they don't really care. You could think about a remora hanging out on a shark. The shark's not really affected, but that remora gets a lot of food from the shark. One of my favorite examples is the pearlfish and sea cucumbers. Okay, sea cucumbers are a really weird little organism. They can basically puke up their entire insides as a defense mechanism. They have teeth around their butts. They're a horrifying little thing. But for some reason, they let this thing called a pearlfish live inside of them. Okay, we don't know why. From all we can tell, the sea cucumber gets nothing out of it, whereas the pearlfish benefits because it's protected inside this thing that has these pretty advanced defense mechanisms, all right? And mutualism, the classic example, is going to be a clownfish and an anemone, okay? So both organisms are going to benefit from this. It helps them both survive, all right? Examples are the clownfish and the anemone. The anemone gets protection. The clownfish gets protection because the anemone is poisonous, and the clownfish can help bring food scraps and stuff like that to the anemone, all right? And finally, all of these ideas come together to create biodiversity. So I started this whole thing talking about the evolutionary history of how we got vertebrates walking on land, and all of that was due to competition, predation, and symbiotic relationships and organisms moving into new niches as they became available. So biodiversity is really all the organisms and species and populations and their genetic variety. So having more genetic variety even within a species is also a marker of biodiversity. We'll come back to this again when we talk about human impacts on the environment at the end of this course, but I just want you to be aware that biodiversity is one of those things that once it's lost, it can take a really, really long time for it to come back. And the reason it's so important, if we go back to the top of this and talk about the importance of soil, there was no soil then. If we actually think about what soil is, it's this collection of all this dead organic matter and bacteria and stuff. But a quarter of all animals or all life on Earth actually lives in soil, and there's still so much there we don't know. The first new antibiotic in 30 years actually just came from studying a bacteria in the soil. So not only is biodiversity inherently good because we should care about the diversity around us because it helps the ecosystem and the world function better, but also there can be human uses there for us to tap into. And if we destroy those, we could be missing out on something really beneficial. Okay, so that's all I have for you guys today. Thanks a lot and stay curious. Bye.